Wait, you said 2-6?
2-6. That's 2-6, right? I want you to go to the notes for 2-6, and we're going to do number 5 and 6 because we didn't do those yesterday. Alright, so with limits, if the limit was going to exist, it had to be the same for both sides, right? So the y value that we're heading towards from this side had to be the same as the y value that we're heading towards from this side. The limit to exist. For the derivative to exist, the slope has to be the same for each side. So it has to match. So, if I have something like this, and I asked you for the slope here at that value, what would you tell me? Like, I don't even know what you would say. Would you choose that slope or would you choose that slope? The real answer is because the slopes are different, the derivative would not exist at that spot. So if the derivative is going to exist, two things have to be true. One is it has to be continuous. And two, the slopes have to be the same. So if I look at number 5, it's asking me if it's differentiable. Differentiable means I am able to take the derivative. And it exists. So in number 5, I can check if that's continuous. So that was last year. We're kind of combining continuous and differentiable here. I can check if this is continuous. Continuous means the limits are the same. So continuous means I would set like that and that equal, or plug -1 into that, plug -1 into that, and see if they're the same. If they're the same, that would be the limit. If they're not the same, what would the limit be? If you plug -1 into each of these, you get two different things. What's the limit? Does not exist. And would it be continuous at that spot? It would not, because you'll have like a jump. So that's the continuous version. So I want to do differential. So f prime of x is 10x plus 3 when x is less than or less than -1. -7, no, -7. That's when x is greater than or equal to 1. So I'm looking at the derivative piecewise, so I'm checking to see if the slopes are the same at our like connecting point there, -1. So if I plug -1 into the top, what do I get? I get -7. If I plug anything in the world into the bottom, I get -7. So that is the slope of this piece, the slope of this piece, they match. So it is differentiable because the slopes are the same for both sides. Questions on that? Try 17, 18, 19. Then we get into the 17, 18, 19. Not if it just says differential. On some of these you'll have to, but like right now, not yet. Right now, if it says it's a differential, you just take the derivative of both pieces, plug it in the x value, and see if you get the same slope or not. That's 6 words. I'll just put the answers up here so you don't have to get your Chromebook out and all that. There's the answers. I messed up. I forgot a thing. No, on all of them. Well, kind of like a general rule. I'm sorry. It's what Russell just asked. So, two things. I'm sorry. So, for a function to be differentiable, I wrote it and then I ignored it. One, it has to be continuous. So how do we check if it's continuous? We plug 5 into that and 5 into that. You do have to do that. For something to be differentiable, it has to be continuous and have the same slope. Not just one or the other. So you should be plugging 5 in and checking that, and then also taking the derivative, plugging 5 in and checking that. That's fine. We will definitely practice that more tomorrow. But if something's going to be differential, it has to be continuous, which means the values are the same when you plug it in. And it has to be differential, which means the slopes are the same when you plug in the derivative.
So you have to plug it in before you take the derivative
A and F, yes. Before tells you if it's continuous or not. After tells you if the slopes are the same.
Well, they're
not the same thing, you just stop.
If the first level's not the same, then it's automatically not continuous, which means it's not differentiable. Yeah, that's why it has to be continuous. Yeah, so I think you're trying to, like, if you just looked at the slopes, you could have something like this, because those slopes are the same, but that's not continuous, so you don't have like a nice smooth line there, and you can't take the derivative there. So it has to be continuous. This is not continuous, right? It has to be continuous and have the same slope. That's what I'm saying. Yes, no, yes. Or yes, yes, no, no. Or are you looking at the word? You get up.
How I did it wrong.
Couple minutes, and then I want to move on to number 6 on the note.
Oh, that's just
oh, yeah, obviously.
say bot? Huh? Did you say bot? Bot. I said your owner's a bot. That's how we say it. Okay, never mind. If you're done, well, you can try 20. Battle your way through. I don't know. Probably more fun than just sitting there. Of course it is. Okay. I would like to come back together and look at number 6, please, on the notes. I can almost promise you there will be one of these on your gateway. Because it allows me to check, can you take the derivative of that? Can you take the derivative of that? Do you know what continuous means? Do you know what differential means? All at the same time. It's a really good problem if I had, because I can attack a bunch of seals with like one problem. Fair warning. So, if it's going to be differentiable, then two things have to be true. One, it has to be continuous. I'm going to do this on like, so continuity would mean that x squared minus ax plus 2 has to equal x plus b. That doesn't look very friendly. I got an a, a b, an x. A lot going on there. I know one of those. What variable do I know? X is 3, right? So 3 squared minus 3a plus 2 equals x. No, sorry, equals 3 plus b. So I could solve that for b, but there's still going to be a variable there. Like this would be 9, 11. If I bring that 3 over, this will be 8 minus 3a equals b. Agree? Does that make sense? Just set them equal, plug in an x. But I can't find out what a and b are if I have 2 unknowns in one equation. So I'm going to need another equation. The other equation comes from the fact that the derivatives have to match. Slopes have to match. So the slope of the first one is 2x minus, what's the derivative of ax? A. And I got to set that equal to the slope of the second one. So that's a 1 in front of the x, and then b is just a number, so the derivative of the number is 0. So that's true, because I'm setting the derivatives equal to each other. Slopes equal to each other. And then I know x is 3. So 6 minus a equals 1. And then if I move the a over there and the 1 over here, it'll tell me a is 5. So that part makes sense. And now I can go back and find out what b is. Because b is going to be 8 minus 3 times a. B is 8 minus 3 times 5. which is -7. So then you're out of your values for A and B. A lot of times they'll say like find that values for A and B and tell me what A plus B is, something like that, and then you'd have to add those two together. So it's a two-part problem. Continuous we've done. We're just kind of throwing in the mix with differentiability right now. One equation is not going to be enough to get it done though, so then I got to do the slopes also. And then between the two of them, you should be set up with enough information to find out A and B. Question I go over that? What numbers are those? 20, 21, 22. So now you should be able to do 20, 21, 22. That should be. I mean, you can, it's fine. I have presented information on 20, 21, 22. Maybe it goes well, maybe it doesn't. We'll see. I'm not worried about the test prep in this section. So if you just do -17 through 22, those 6 problems, you're all good. Third root of -1, right? Square root you can't do, but third root you can. It's -1, not -1. Like an odd number will come out negative. Yeah. Where, which ones? Second part? If it's too annoying to go look at your book or the answers on the Schoology page, I put them up there. Please ask if I can help. There's lots of little things in here that can come up that can screw you up. Which is like a fresh one. You said. So what does it mean?
Stop walking for the board, goodness.
Goodness.
It's a lot more work.
No one got one.
we talked about like negative fractional exponents that we talked about? So if I gave you like negative 8 to the 2/3, what is that? Not negative 6. Not a calculator. Well, it might be now, but I don't want it to be. No, it's close. What? It's 4. So the number on the bottom is the root. So you're gonna like go down. So what's the third root of 8? It's like what number to the third power gives you 8? I'm sorry, gives you negative 8. It's negative 2, right? It's negative 2 times negative 2 times negative 2 is negative 8. So that's the root. You do that first. And then what we just got, which was negative 2, you raise it to that power. So it's really like negative 8 to the 1/3 squared. And then this is where your 2/3 comes in. So negative 8 to the 1/3 is negative 2. Squared is 4. Did we practice that stuff or no? We haven't. Okay, we might need to soon. Is that familiar? Okay. So if we need to brush up on it, we